Welcome to my video. In this video we're going to look at the sorting algorithms for AQA's GCSE in computer science. We are going to compare the merge sort and the bubble sort and look at the advantages and disadvantages for both. You'll need to know these for your exam. In the exam you'll also need to know the key steps of the merge sort, so let's recap those. The merge sort starts by dividing the list into two, and this repeats until the elements are separate. This is the end of phase 1. The elements are then compared in pairs and placed into sorted order and combined. This process is then repeated until the list is recompiled into a sorted list. Remember, the merge sort is an efficient method of sorting data, and it uses a technique called divide and conquer. Here is an overview of what a merge sort looks like. Above the dotted line is phase 1 and below the dotted line is phase 2. You can see here how phase 1 is breaking it down into individual items, and you can see here how phase 2 is comparing them and recompiling the list. Let's look at phase 2. Phase 2, it takes, look here, the 25 and the 17, and it knows that 17 is less, so the 17 is placed first in this list and the 25 is placed second. This is the same here. The 26 is less than the 34, so the 26 will come down, the 34 will come down. The same process here and here. We would then have 4 lists. We would then do the same here. We'd look at the smallest in this list, which is 17, and the smallest in this list, which is 26. Well, 17 is less than 26, so the 17 comes down. Now, we've got 25 in this list, and we've got 26 and 34 in this list. The 25 is compared against the 26 because it's the smallest in this list. 25 is smaller, it comes down. There's nothing less in this list, and these two are already in order, so we just bring them down. We would repeat the same process here. We would then end up with 2 lists, and would repeat very much the same again. Here, we'd compare 17 against 20. Well, 17 is less, so the 17 would come down. We'd then compare 25 against the 20, because 25 is the next smallest in this list. Well, 20 is less than the 25, so the 20 comes down. We then compare the 25 against the 28. Well, 25 is less, so the 25 comes down. We then compare the 26 against the 28. The 26 is less, so the 26 comes down. We compare the 28 against the 34. The 28 is less. We compare the 34 against the 37. The 34 is less. 37 and 39 are left in this list, and there's nothing left in this list, so these just come down. And that is the basic process of a merge sort. Let's look at the overview of a bubble sort. A bubble sort compares each item to the item next to it, and if they're not in order, it will swap them. The algorithm finishes when no more swaps need to be made. It takes the largest item and bubbles it to the top, and it does the same for the smallest item, but it bubbles it to the bottom. It's a very inefficient sorting algorithm, however, it's very easy to implement, and it's a great choice for very small lists. As a basic overview, the bubble sort goes through a number of passes. It basically starts at the start, and it looks at the first item. In this case it would be 25. It would compare it to 17 and it would identify that 17 is less, and it would switch them, so the 25 would move to here. The 25 would then be compared to the 34. 34 is greater than the 25, so the 25 would stay here. The 34 would then go on to compare to the 26, and the 26 is less than the 34, so the 26 would come to here and the 34 would come to here. It would then compare the 34 against the 34. They're the same, so no swap. Okay, and this would continue all the way through until the end of the first pass. At the end of the first pass, it would be more than likely that the data would not be in order, so it would come round and go again to the second pass. It would repeat for a number of passes until there are no swaps made. This means that the data is then in order. I have placed here an overview of what a bubble sort looks like. I've colour coded it so you can see how the data ends up moving from one end to the other, and this is called bubbling. A 20 is a good example of this. If you are unsure of this or you need a little bit more guidance, I have a video in my playlist on this. Please feel free to go and watch it. Let's look at the advantages of a bubble sort. The advantage of a bubble sort is it's a simple algorithm and it's very easy to implement on a computer. Due to the fact it only compares 2 items at one time, it doesn't use much memory. It's an efficient way of checking very small lists, or lists that are already in order. So for example, here's a list that's already in order. It would literally go no swap, no swap, no swap, no swap, and that would be the end of it. Hence why it's efficient for small or lists that are already in order, because it would only have to run through them once or a very small amount of times if it's a small list. The key disadvantage of the bubble sort is it's pretty slow on large lists. It takes a very long time. So let's compare that to the merge sort. The merge sort, it's quick for large lists because it doesn't compare the whole list. It doesn't have to go through it numerous times. Okay? It's good for sorting slow access data, such as data on a tape or a hard drive. but the key disadvantage of the merge sort is it uses more memory to store the data due to the fact that it's splitting the list into sublists. Thank you for watching. I hope you enjoyed this video. If you need a little bit more information on the bubble sort and the merge sort, please go back into my playlist. I have a video on both of those in which I go through them in depth. Thank you.